So going into the next topic, so let's look at some key terminologies. Okay, when we go to the future slides, so this will help you understand better. So let's look at some key terminologies here. So first, let's focus on what is a spectrum, what is a band, and what is bandwidth. So spectrum can be defined as all the useful frequencies available to us for various purposes. So what are the various purposes? It can be whatever I gave you in the previous slide, all the applications that you can think of in terms of defense, safety, space, entertainment, communication, and so on. Okay. So you may have, if you ask me what is spectrum, you may have heard of all the spectrum options that auctions that happen in India. So if you have heard of the famous 2G spectrum scam, so you can think of why spectrum is so important. So spectrum is like a precious natural resource. Okay, think of it as water or oil or gold. So obviously government wants to have a control over it. So government has a control and government allocates it for different purposes. So that's why it is very critical. So this is a picture which you cannot see. I think it's a very small font size, but I'll give you a reference link so you can note down that link. And what I want to show in this spectrum chart is this is a US spectrum chart. Okay, so it is showing all the frequencies starting from 3 kilohertz on the top left to let me take my pointer here. So you can see it starts from 3 kilohertz here and it goes all the way up to 300 gigahertz. This is a US spectrum chart, but you can consider this applicable to India or rest of the world also. Okay, so you can think of this all the frequencies that are available with the government for various purposes. It doesn't mean that I can pick any frequency here and I can start designing a system. It's not like that. So the government has to allocate to a particular purpose. Okay, what is 4G when it come to 4G and 5G spectrum, right? So we focus on microwaves. So what is microwaves? So a radio frequency or microwaves, as I told you, these two terms are interchangeably used. So you can think of RF or microwaves. It is used for radio communication. So anywhere you see something is called as a radio communication, you can think of we are using radio frequency or microwaves. So when we talk about micro and waves, right, we have to talk about wavelength. What is a frequency and what is a wavelength? So if you look at this particular image, I'm sure you have seen this is a simple sine wave. What you see here is for every sine wave, you have a wavelength, right? So this is the distance that is covered by one cycle of a wave. So this wavelength is very important, and that's how we define different terms in whether in 4G or 5G when we talk about microwaves or when we talk about radio frequency. How we group it is always based on the wavelength. So then the question is, why do we call it as microwaves? So initially in earlier days, long back when the communication was started, it was mostly in low frequency and little bit of higher frequencies. We call it as VLF or VHF frequencies. So as the technology progressed, government started allocating new spectrum. So the new spectrum was much higher in the range. So if you look at the spectrum chart, so the initial frequencies were somewhere in the lower frequencies range. So as government started allocating frequencies in the higher frequency regions, so somewhere here, so we could see that the frequency increased. That means the wavelength reduced. So since the wavelength reduced, there was a new term that came into picture that was called as microwaves, because now the wavelength was smaller compared to the previous system. Okay, so that's why it became micro. So previously the frequency was lower, that means the wavelength was higher. Later, when we started getting newer frequencies which were in higher frequency domain, the wavelength became smaller, and that's how we got this term as microwaves. So how is frequency expressed in let's say in 4G or 5G? It is expressed in megahertz and gigahertz. Mega is 10 to the power of 6, giga is 10 to the power of 9 hertz. So let's highlight one portion. So if you see this picture here, you can see a small rectangular shaped image here. So that is zoomed in here. So if you can see here, this is the radio spectrum. Okay. So it is called as a radio spectrum because this is the spectrum that is used for radio communication. So on the axis here below, you can see it, you have all the frequencies. It is showing, let's say, from 10 kilohertz, 100 kilohertz, 1 megahertz, all the way up to 100 gigahertz. Now on the top, if you see, this is all wavelength. So you can see 30,000 meters, and it goes to all the way up to 0.3 centimeter. So when it goes to 100 gigahertz, you are talking about 0.1 or 0.3, in that range. You're talking about millimeter. Okay, the length here is wavelength is in the lower centimeter, sub centimeter, or millimeter range. Okay, so this is something that you can look up online. So this picture is available. So wavelength, as I told you, when the frequency is in, let's say, megahertz or gigahertz, so wavelength will be in centimeter and millimeter. So these are the references you can always type. So if you type ntia.doc.gov, or you can type US spectrum chart on Google, and you will get this image. Okay, going to the next slide. So now we discussed what is a spectrum. So spectrum is all that, lot of frequencies that you saw in the picture, from 3 kilohertz all the way up to 300 gigahertz. All that is the huge spectrum, but we cannot use everything from that. Okay, so then we define something called as band. So band, it's a chunk or blocks of frequencies within the spectrum. So within all that huge spectrum, so there are only certain blocks of frequencies that we can use. So these blocks, they may not be contiguous. Means you may not be able to get continuous, let's say 100 gigahertz together. So in between some blocks you may get some blocks. If you go to the previous slide, I'll show you here. So you can see there are different colors, right? So what these different colors represent, that you cannot use a contiguous frequency. You won't get this complete rectangle here, for example. Okay, there are different colors. That means when there is a different color, it could be used for a different purpose. Okay, so that's what I mean here, saying there is a lot of unavailable spectrum in between. Why it is unavailable? Because some spectrum in between could be used by government, it could be used for defense, it could be used for space, so you cannot use that. Then within the available spectrum, it could be shared with operators. Let's say Airtel has a particular spectrum, Geo has a different spectrum, so you cannot use, Airtel cannot use Geo spectrum, so there are that limitations. Then some are used for public use. Okay, so whatever is used for public, let's say police, for the safety, they use it for some emergency purpose, you can't use that. So there is a lot of such limitations. Now, when it comes to, let's say, 4G and 5G, the global definition of the frequencies, the bands, so it's all defined by 3GPP. So 3GPP is a standards organization. Okay, so this is a worldwide organization. So they define what are the frequencies, how you can allocate it, what it can be used for. It's all defined within the 3GPP. So its full form is Third Generation Partnership Project. Now, if you focus on 4G and 5G bands alone, right? So 4G, if you look at this 3GPP document, so 3GPP, I told you, is a standards organization. So if you look at this 3GPP documents, you can see that 4G has like 50 plus different bands. And what is the range? It falls from 700 megahertz to 6 gigahertz. So I've given you here an example of one of the India bands, so B40. It's also used in other countries. So you can see that it ranges from 2.3 gigahertz to 2.4 gigahertz. So this is an example of one of the 4G bands. Now what happens if we go to 5G? So it has 40 plus bands. Again, they fall within a range of 400 megahertz to 7 gigahertz. So if you see this range, 400 megahertz to 7 gigahertz, it is pretty much same as 4G range. Okay, so it's also called as sub 7 or frequency range 1. FR1 is called as frequency range 1. Okay, this is all defined in the standard, in the 3GPP standards. Okay. Then what is the second range? So second range, see here it started from 400 and it ended at 7 gigahertz. Then there is a second range which starts from 24 gigahertz. It goes all the way up to 53 gigahertz. Okay, this is called as FR2 or frequency range 2, and commonly used term, you can see in any article or online items, they call it as millimeter wave. Okay, so now why we call it as millimeter wave? You remember this sine wave that I showed in the previous slide. So we were talking about the wavelength. So here wavelength at this frequency range is typically defined in terms of wavelength of 5 to 10 millimeters. So it is easy to express in millimeters, while if you compare FR1, it can be expressed in centimeters. So millimeter waves, FR2 expressed in millimeters, that's why it is called as millimeter wave. Okay, band grouping. Now that there are multiple bands, you see that we saw it goes from 700 megahertz to 6 gigahertz, or from 400 megahertz to 7 gigahertz. It can go from 24 gigahertz to 53 gigahertz. So how do we all group it? So every day when you're talking, let's say you're working in Qualcomm or Intel, if you want to talk about how do you group these bands. So when you're designing a product, right? So at a high level, you can call it as low, mid, and high bands. So you can see this picture on the top right. So typically, this is how it is defined. So low bands is something up to 1 gigahertz. So mid bands is somewhere from 1 gigahertz to 10 gigahertz. So high bands is something about 24 gigahertz. So in this example, if you look at B40 that I have given 2.3 gigahertz to 2.4 gigahertz, you can think of it as calling it as a mid band in 5G. Okay, let's go to so these are the references. So now that we have discussed about spectrum, band, and let's discuss about bandwidth. So what is a bandwidth? So dedicated frequency range within the band. So think of spectrum as that big picture that I showed you from 3 kilohertz to 300 gigahertz. So within that we had, let's say for 4G and 5G, we had certain bands within that big chunk, some colors within that big chunk. And within a band, again, there is something called as a bandwidth. So what is a bandwidth? So you have a dedicated frequency range within the band, which is allocated to a user. So what do you mean by this? Let's say if you are a user and if you are, let's say you're on Airtel or Jio or BSNL, you're using a phone, you're making a voice call or you're making a data call. So you are given a small frequency range within that band that I talked in the previous slide. I showed you about band 40. So for example, within that small range, within that band, you are given a small chunk of frequencies. So that frequency allocation to your particular use is called as a bandwidth. So it is given to a particular user. I'll show you a picture. So this is from the 3GPP document. So whatever I showed you in the previous slide, the 3GPP is a standards organization. So if you look at their specification document, they define a channel bandwidth, something like this. Okay, so don't worry about rest of the terminologies. So those you can always refer online and you can read up. So what you have to see is they define a channel bandwidth in, let's say, in megahertz. So think of this channel bandwidth as a group of frequencies within a band. Now, unlike 2G and 3G, it is flexible in 4G and 5G. So what happened in 2G and 3G was this bandwidth, whatever you see here, it was fixed. Okay, this was the size, for example. Let's say, okay, it is defined in megahertz. Okay, it was fixed. So in 2G and 3G, this bandwidth, which was defined in kilohertz or megahertz, it was fixed for users. So what is the problem when you fix a bandwidth? Let's say you are a user who is playing an online game. Okay, there is one user who is playing an online game. So that person requires a lot of bandwidth. And let's say there is another person who is just reading a newspaper online, okay, online newspaper. That person probably requires very less bandwidth because on a newspaper you probably have only text, right? There are no moving parts. But in an online game, maybe you are using high data rate. Now, if you fix the bandwidth like in 2G and 3G. The disadvantage was it was not being efficiently used. So when a user wanted less bandwidth, it was still, that user was still allocated the same amount of bandwidth. So basically you are wasting the bandwidth. And I told you before, think about it, spectrum and the frequencies is like a natural resource. Okay, it's very precious, it's very expensive. So we don't want to waste it. We want to put it to proper use. So that's where in 4G and 5G, we got that flexibility. So based on the user requirements, we could have flexible bandwidths. So if you look at here, I have given, all these numbers again are from the 3GPP specification documents. You can see that we had a flexible bandwidth option, 1.4 megahertz, 3 megahertz, 5 megahertz, 10 megahertz, 15 megahertz, 20 megahertz. So all these are different options. Now what happened as we went to 5G, we definitely have the flexibility, but we added a lot more bandwidth options because we are also thinking of one of the important criteria in 5G is also again high data rate, right, or high bandwidth. So we are retaining what we had from 4G. We are also adding more options, right? It can go up to 100 megahertz. And this is in FR1, that is a frequency range 1. Then what are the bandwidth options in millimeter wave? So millimeter wave, we can go up to 400 megahertz. Okay, so this channel bandwidth, what you see, we can go up to 400 megahertz. So this will support your high data rate applications. All these, when you have higher bandwidth, you can go for higher data rate applications. Okay, now we have studied three terms: spectrum, band, and bandwidth. So let me put it together. So I hope this looks like a train for you. If not, please imagine this is a train. Okay, so think of this as a train. So this train is all the microwave spectrum that you saw. Okay, all the spectrum. So now within that microwave spectrum or the radio spectrum, let's say when I say radio spectrum, we are not talking about that 3 kilohertz to 300 gigahertz. We are not talking that entire part. We are talking about that small rectangle that we saw on the bottom, which is only radio spectrum. Think of this train as that radio spectrum. So within that radio spectrum, you can think each of these blue colored bogies as the band. Okay, this is a band. Now within that each of the bogie, you can think of each of the berth or the seat as the bandwidth. Okay, so that is what is given to each user. Now, can you get more than one seat? Yes, you can definitely book more than one seat if it's a high data rate application, but you have to obviously pay more. Otherwise, you are allocated just one seat. So this is a high level way to look at spectrum band and bandwidth. Go to the next slide. So these are the references. So this is the reference that I was telling you, and this is the specification number. Please click on like and subscribe to our channel and click on the bell icon for regular updates.